on the other. But after spending half an hour trying to get that screen to work, I decided to just simply stay with this one. Okay. So I promised to say something about command line sorcery. I'm going to assume that you know a lot of the trivial commands like RM, CP, LS, that kind of stuff. I'm going to talk about some more obscure stuff. So I want to talk a little bit about what the shells are and a little bit of the history of the shells. Then it turns out that shells are actually programming languages in their own right. And we can program in a shell. And so we're going to talk a little bit about programming in the shell. We have variables. In some shells, not all of them, we have arrays. We're going to talk about how to do arrays in one of the shells. We're going to talk about composite statements, about pipelines, how to use reverse quotes, and I have a very perverse example. And then we're going to talk about some shell control structures. Then I'm going to talk about shells as interpreters, because everything we're going to do is going to be interactive up to this point. I will see whether we have time for some examples, how to use some of the commands available at the shell level as database tools, although you probably have an idea by then, and maybe talk a little bit about personalizing your prompt. It's kind of big. Okay, so what is a shell? A shell is a Unix program. Well, actually, it's a program, because there are shells which are not Unix. It reads text from the user. It interprets them as either built-in commands or commands that require execution, as require invocation of a program. If it requires the execution of a program, it will wait for that to finish unless you tell it otherwise. Okay, the difference between what a built-in command is and what is not a built-in command varies widely. In the following sense, what you type in to some shells may be built in, and another shell may not. Okay. For example, the original shell did not have built-ins for test or echo. Modern shells do. Yes. You had a question, Elias? Oh, okay. Okay, so what Unix shells are there? Well, the very first shell was called SH, written by a guy called Warren. It was added very soon after Unix was originally created. And it was actually quite fancy. It already allowed programs to be written on it. It was quite speedy for execution. Let me give you an example. In those days, Unix ran on small machines. By small, I mean that it ran on a PDP-11. The PDP-11 was a machine that had 64K of memory. Unix ran on that. By contrast, we had another computer also built by the same company, Digital Equipment Corporation, called the KO-10, which used binary arithmetic. Well, they both used binary arithmetic, but it used 32-bit words. No, actually 36-bit words. And it had 256 KO. It also had a command language interpreter, but it ran 100 times slower than the shell on Unix on that PDP tape. Okay. The next one, well, the syntax was very nice from a computer science viewpoint. But there were a lot of people who were confused. You see, Unix came with a language called C, which is the grandfather of C++. And the language syntax of SH was nowhere close. So it was very confusing. Plus, SH lacked a lot of things which people liked. Among other things, because a lot of the people who were outside of AT&T when Unix was created were used to an operating system called 10X. And 10X had a lot of nice features, some of which were job control and aliasing. That is, giving a name, a short name, to a command. So in 1979, a project came out called the C shell. And the C shell added job control, aliasing, and it had a C license. Those are the good news. The bad news is that the I/O control to the C shell is a disaster, and it has lots of bugs. To be precise, the way to specify interrupts is much nicer in SH than CSH. I/O redirection is a lot nicer in SH than in CSH, etc., etc. There's a paper which I can give you the reference to as to the top 10 reasons why SH is not a good shell. Okay. So this ended up with a situation where a lot of people were using CSH, which is nice for an interactive language, but awful for writing scripts. So people would use CSH for interaction and SH for scripts. So here we have what came afterwards. Well, I told you that a lot of people like the 10x things, and they added the 10x things to CSH, which are command argument recognition and completion. What that means is that when you start typing the command, you can then hit tab usually, and if it's unique, it'll complete it for you. Well, on the other hand, there were other people who didn't like what was going on with CSH. In particular, there was a purist at AT&T called Korn, K-O-R-N. So he wrote a variant of SH called KSH. And he unleashed that on the world. Unfortunately, he didn't really unleash it. He just simply said, here, you can have this, but you've got to pay for it. People were not. So, in particular, there was a guy who was not happy at all with it. And he had a big project for an operating system for the people called the Bird. His name, I think, is familiar to a few people here, is Richard Stallman. Anybody heard of it? Mm-hmm. Okay. So he decided that an operating system had to have a free shell. And CSH and TCSH didn't cut it. So the Free Software Foundation produced their own shell called Bash, which was released in 1989. AT&T, noticing the error of their ways, released KSH to the public in 1990. By then, also, there was another version of KSH called PDKSH. 3 guesses to what PD means, also around 1990. Now, another guy was also trying to get a shell for their project, and he didn't like what he was doing, so he tried to get a very simple shell going, and he produced something called RC. Very simple shell. But unfortunately, although it's superficially similar to SH, it really isn't. It later was enhanced into something called ES. CSH was also developed around 1990, but the first stable version wasn't produced until 2007. Okay, quite a zoo of shells, right? Now, Eli, you mentioned fish. Is fish also a shell?
Serves the same purpose, but not quite.
Yes. But I also didn't mention another shell. Section. Standalone shell with built-in commands. Most computers have SASH available. Why? SASH is probably a simple implementation of SH, but the nice thing about it is that it has a bunch of all those utilities you like MD, CP, LS, and so forth, built in. I told you what's built in is in the eye of the beholder. And so, SASH has all of those things built in. What is the idea? Well, if your system is crashed, or almost crashed, but you want to see what you can salvage, at least here's a program with which you can work. Okay? Okay. So, unless your system is crashed, you have to choose another shell. So if your system is not trashed, you have to choose a shell. Which shell do you want to use? I told you CSH and TCSH have problems. SH, KSH, and Bash don't have vectors or arrays or anything like that. And that's nice. ZSH suffers from something called feeding creaturism. Anybody knows what that is?
It's too customizable.
Huh?
It's too customizable. It has too
No.
many things in it.
Feeding creaturism is a hackerism. Actually, if you take the CR and put it here, and you put the F and put it here, you get creeping featureism, which is, imagine a monster, which is features, which is gobbling up the system. That's pretty much the problem with ZSH. It's got features and features and features and features all over. It's got so many features you don't know what to do with it. I took the liberty of printing out a ZSH reference card. This is for ZSH 3.4. It's got 7 pages in it. That's more than the thief reference card. RC and ES have a somewhat different syntax from all of the above, and they have some limitations. So, it's up to you. What do you want? Some people prefer bash. Some people prefer ZSH. Please, please, please. If you have a choice, don't touch those in the first line. Now, consider me. When I started dabbling with Unix, it was 1980. Go back a few slides. What was available in 1980? SH and CSH and then TCSH. By the time TCSH came out, wait a minute. By the time the mid-80s rolled around, the only players available were TCSH, CSH, and SH. The university could not afford to buy ASH. So it was either TCSH, CSH, or SH. I had no choice. It was TCSH for me. So, I'm stuck. Now, preparing this talk today, I ran on a nice little script called C2Z, which apparently offers a nice way to go from C shell to Z shell. I'll explore it when I have some time. Today, I'll use ZSH. Incidentally, I do have a Mac. Guess what I use on the Mac? Bash. Why?
It's the default.
Huh?
It's the default.
That's the default. I don't want to fiddle with something I don't know how to change easily. I could probably change it. It's probably the user preferences or system preferences or something like that. I haven't taken the time. Okay. There's an article which I downloaded, and I'll probably paste links to all of these articles as they are on the net on my website in the next few days. One of them is what shells are there and how to create your shell. And there's also a link, there's also a post on Wikipedia about a comparison of the different shells. It's got a very interesting comparison. oodles of pages of the different characteristics. Okay. So let's talk about variables. Notice that a variable, very simple. You simply write the name of the variable you want to set, then an equal sign, and then the value you want to set it. The value can be either a string, and you don't have to use quotes, or it can be a number. Shells are string processing animals. So whether it's a number or not, it's still a string. And it's only when you try to do arithmetic or something like that with it that it actually gets turned into a number. Okay. A word about quotes. Now, first a word about how to dereference a variable. Okay. Told you everything I'm going to do here is use CSS. Okay. So quit and get nothing. So now, next time I'll do it, I can do that at my leisure. Did you notice that my prompt changed? My prompt gives me the time here. My prompt gives me the time, the host I'm on, and the directory I'm on. Here, it gives me my username, the host I'm on, and the directory I'm on. Incidentally, that is the default prompt for ZSH. This is a customized prompt for the GCSH. I prefer getting the time, although it's not really that useful. Why isn't it that useful? Because it usually sits there forever. And when I look at it again, well, it should probably change a little bit. Is it? Yep. It's now 1948. Okay, so let's set a variable. Value. Okay. Now, the way to print out the value of a variable, the way to get output on a shell is the echo command. But if I say variable, look what happens. How do I get my value? Prepend with dollars. Okay? Incidentally, many of the shells, in particular TCSH, ZSH, I think Bash also has it right now, offer facilities for editing your input. So you hit the up arrow, you get the previous line. And if you hit up arrow or control P more times, you go back in your history. And then you can move the arrow. You can move with the arrow back and forth on that line, editing as you go. That's what I did just now. Okay. Now sometimes I'd like to add some stuff to it. For example, tells me there is no such variable as variable AS. Because really what I want to type out is ABCDE AS. So what I can do in that case is I can enclose the variable name in braces like this. Correct? No. Oh. There we go. Okay. So that's, in a nutshell, how to add a variable. There is a lot more to variables than I said here. For example, there's a way of specifying, okay, give me the name of the value of the variable, but if it's not specified, then give me a 0 or give me a blank or give me whatever. But I won't get the code. Arrays. There are two syntaxes. One is older, the first one. The second one is newer. To set arrays. This works in ZSH. It does not work in Bash. Sorry, I'm bashing Bash. Sorry about that. The first one, set -a, name, and then a bunch of values, sets an array to those values. I can also go name equal open paren and then a bunch of values close paren. For example, set -a. Yeah. -a, array 1. A, B, C, D, E. Or I can do array 2 equal open paren A, B, C, D, E. Okay, so we can print them out in total. Here's a nice little trick. If I want to repeat the exact same command with just a little change, I can use the caret like so. Caret changed 1 into 2. Okay? Okay, now we want to know how many elements are there. Well, I can use this. Yeah, there are 5. And so I want to find out what is uh-oh. I better use the dollar sign there. Like this. Tells me my indices start at 1. That's not C, is it? That's not even Python. Okay. Now here's something. Let's see, how we do there. Let's do this. Let's print out a rate sheet. Let them up. I could also do it, I've done something like this. Okay? So there's lots of things you can do with arrays which are fun. Okay, here are some commands which I'll probably use. These are commands that follow. I'm going to explain a little bit about them. I won't go into the full details. But let me go over them one by one. File. File will look at the file and give us a description of what the file contains. It will not look at the name of the file, rather it'll look at the contents. It is not fooled by the file name. So you can take a file, give it any funny name you want, and if it was, say, a graphics file, it'll say it's a graphics file. For example, how many of you have done some internet browsing and wanted to get at some of the files that that you saw in your session and then went to the cache? Anybody? You did? How, what did the cache look like? Jumbled mess, right? Bunch of files with names that didn't represent anything whatsoever, right? Well, You can go file at all those things and I'll tell you what they are. Okay? I'll go into an example with that later. Cut. As the name says, it'll cut the file into parts. So for example, you can say cut of, say, the first two fields, or the third and the fourth columns of file, and I'll cut them. And paste does exactly the opposite. Now take two files and paste them together. Now sometimes you don't want to really do that, but you want to sort of paste them together depending on some field. Well, that's what join is for. Do you know how to use the shell for database management? There it is. Just use ASCII files. Okay. Find. Find is a program that'll go from a directory down all the way you want and look for all the files whose name follows a certain pattern for other attributes. You can, for example, check for files which have been created after a certain date or before a certain date, or have certain permissions or belong to somebody, etc. The man page for find is expensive. You notice that I skipped awk. Awk is a programming language. But awk is also a very nice utility. Let me go over awk since find is almost as complicated. Awk, the way I use it, I give awk a parameter in quotes, single quotes, which has two parts. The first part is a pattern, a regular expression. And the second part, in braces, is a print command, or a sequence of print commands. And what it does is it separates for me those fields which I want corresponding to the lines which match the pattern. I'll explain in a little while. Locate is similar to find, but it only applies to a database that has already been set up periodically by the system. I think I turned locate off in my system because it's a bugger. grep. Grep is another one of your database programs. Grep, what it does, and it's one of your most useful utilities, really. You give grep a pattern and a bunch of files, and looks in all those files for that pattern. Okay? Okay. Set is short for stream editor. And you'll have to use the manual page for that. Set is basically for doing short additions in a batch format. For example, if you wanted to replace all strings in a file of one form to another, instead of calling up Beam, doing the addition and then saving it, you can just use that and do that. Sort. What does sort do? You have 3 guesses.
Thinking it sorts stuff.
Huh?
Thinking it sorts things.
Exactly, it sorts. And together with sort, I forgot to put in another one. It's called UNIQ. If the input to unique is sorted, it deletes a repeated instances. That's part of my cavern scandal. Man. Man, as short for manual page. You say man, string, and it'll look for that string and print out the information corresponding to that command, or that system call, or that subroutine, library routine, etc. Depending on which chapter of the manual you're talking about. On Linux systems, you also have info, which gives more information than man will do. BC. BC is a handy little calculator. Infinite precision. I think I blew the minds of the people in my software security class the other day when I computed Dr. Tutorial exactly using BC. It's 3 lines of digits. Cal. Cal's another little utility. It'll print out the calendar for any year, or if you want, any month of any year. It compensates for leap years and assumes we're using, I think it's the British calendar. So I think it skips 13 days in 1763. Date gives you the date and the time. Touch. Touch does one of two things. Touch, you give it a file name. If the file does not exist, it creates an empty file with that name. If the file does exist, then it modifies the creation time of the file to the moment when it executes the touch. Okay. Cat is short for concatenate. Cat, you give it several arguments, and what it does is it outputs the contents of all those files together. Okay? Now it's handy when a file is short to print out the contents of a file. But when a file is big, you don't want to do that. So when Unix was invented in the 70s, terminals, well, especially the terminals used at Bell Labs, were TTYs using paper. So when you did a cat of a file, the file would just show up on the paper, and you could then study it at will. Since it also printed out at 15 characters per second, you could actually read it while it printed out. No biggie. However, by the mid-70s, terminals started appearing. In particular, I remember that the terminal I used in 1976 at the University of Utah already worked at 1200 baud, which means 120 characters per second, roughly. At that speed, with a 12-line screen, there's not much you can see of a 24-line file. Forget a 100-line file. So that's where the people at UC Berkeley, same people who came up with CSH, came up with more. More is just simply a program originally. It will just simply display the first 24 lines of the file, then it'll give you a little prompt more. Then it'll print the next 24 lines and so forth. You have to actually see that, something like that in Windows 2, haven't you? Well, people being what they are, more started getting bells and whistles and more whistles, and people didn't like what they had. I in particular didn't like it either. So people started working on different alternatives. And so somebody came up with something better and more, which is less. A pun isn't money. So less is really the program you want to use once you want to have your screen filled a little bit at a time. Okay, I didn't say what T is. When you're typing, what is a T? What is a T?
The only time I ever used it is whenever you want to do like a sudo write from bin.
No, I've used it occasionally.
Yeah, that's when I would use it most.
T can be used sometimes when you, okay, I'll go over T when I'm using, when I'm talking about bytes. Which is the next slide. Composite statements, pipelines. Okay. The vertical part can be used to represent a pipe. So I can type command, type, command, type, command, type, command, type. The idea in Unix is that every command takes some input, does something to it, and sends it as output. That is the idea. That is why you're talking about standard input, which is the input you get, and standard output, which is the output sent on its way. And a program that receives standard input and produces a standard output is called a filter. And if you have a bunch of filters like this, you can form a pipeline. The pipeline can be of any length. So for example, say you want to have a file. A file consists of, it has columns of information. Okay, for example, the first column is last name, the second column is first name. And you want to sort it by last name and then first name. Well, the way to do that is you sort it first by first name, and then you take that same file and sort it by last name. And then all those that are sorted by last name come out with the first name in order. Okay? And you can do that with sort and a pipe. And of course you can follow that with another pipe going through less. And if you want to save the file, you can use T. So it would look something like this. Let's say your first names are second field. Of course, this will not work because I don't have all DB. And then you pipe that to sort -1. And then you pipe that through T output. And then you pipe that through S. Now what this will do, sort through, on the second field, I think that's the way to do it. Oh no. K2 minus K1. So it uses the second field as the key. Here it uses the first field as the key. Then T will save whatever's going through in the field file output and still send it to a standard output so we can look at it. Okay? Okay, of course it will not. Sort of open fail, DB, no such file out directly, and then let's say, okay, that file, that page. Okay, another example. Let's say I want to look at all the commands related to a database, but only those from the first chapter of the manual. Now, the way to find out all the files, all the commands related to a word is go man minus k word. Watch what happens when I do that. That's an awful lot. Now, notice that here I get the part of the chapter in the manual where that page comes from. So I can type that through grep, and this is a fixed string, namely open paren 1. So I'm using only those in page 1 of the manual. And now I want to have it paginated so it doesn't scroll all the way out. What? Check to make sure that I didn't make a mistake there. Oh, it's capital there. Yes. Okay? So we have everything that has word in it somewhere. It's still a little bit big. So I could probably tell it to check only those that have word as a word. And that would probably just be done with that. Okay. Reverse quotes. In the shell, I can use reverse quotes to substitute the output from the command or the pipeline that is between those reverse quotes as the arguments in those reverse floats. Okay? Huh? So you want to see that in action?
Yeah.
Okay, let's see who's on the system. Okay. Are you sure that's the case? That SQL has processes running on the system. To do that, I developed a nice little script called real. Let's see what it does. Oh, thank you very much.
You're sending messages.
Okay. The first thing I do, PS minus EF, does a listing of all the processes running on the system. Okay? Now, if you would mind not interrupting me, I would be very appreciative. Thing is that by now, whenever you send me something, it clobbers whatever I have on the screen, so it does interfere. Okay. The next thing I have is up, and then an exclamation mark, and then I have a whole slew of exceptions. Namely, I'm not interested in root. I'm not interested in this guy. I'm not interested in this guy, or this guy, or this guy, or bin, or XFS, or user 68, or Devo class, or Hobbit, or MTP, or RTC, or SMMSP, or UID, or VM. So all those that do not match any of these, I print out the first parameter, which is the username. Then I sort them so they turn out in alphabetical order. Then I delete the repeated ones. Okay. Now, why do I do an echo reverse quote, this whole thing reverse quote? Because if I didn't do that, they would come out in a column. This way they come out in a row. Watch. Okay? Okay. Did it go on? I've just started.
Well, I mean, we technically, how long do we technically have room for?
Why don't we take a vote, eh?
Let's take a look.
Vote to adjourn?
I gotta
Yeah, I'm gonna raise my hand, I'll be brave.
go check this out.
Yeah, that's fine.
How many nays?
So I guess yes, we.
Kevin's gonna stick around for that.
Huh?
Kevin's gonna stick around for that.
Can we at least get the slides online?
Oh, yes.
Okay.
Can you
make it so everybody but Kevin gets the phone? Do we have the technology?
Well, we do. The thing is, we do.
Just backtrace his IP address.
I'll build a GUI interface in Visual Basic.
He wanted to end.
Yeah, what
Was that a hacker's
follows now
reference?
is test
That was a
command.
CSI.
Of course, I only have here the syntax for test. The test has a whole slew of options. It allows you to check for whether it's a file, whether a file is a regular file or a directory or readable, etc. And then you have if statements, for statements, while statements, case statements, subshells, functions, and then you can put the shell, you can put a bunch of commands for a shell in a file and execute them as a command. That's pretty much it.